Good afternoon, everyone. Welcome to the last webinar of this year's series of Zoomat Technology. It is my honor to welcome you here as the host of today's webinar. My name is Barbara Chesakova, and I will be guiding you through today's topic. As I mentioned, it is the last webinar of this year's series, but there's no need to be sad if you don't want Zoomat Technology 2021 to end yet. Just head to the website zoomattechnology.com, and if you missed the previous webinars, you can watch them from recording. What was the topic of the previous webinars? Well, we started with renewable resources. We continued with ecology on the more traditional sources of energy. And then we followed the path of electricity and energy from the source to the customer. We were talking about storing and monitoring this energy, using it, collecting data, visualizing them, and then using this data and this visualization in your everyday decision making. We introduced both of our platforms, Sandra and Simone. And if you are interested in it, you can just see the webinars. And if you are interested in the field of healthcare and what modern times bring as challenges into the healthcare industry, you can also watch the last webinar where we talked about our competencies for health industry. But this is not why you came today. You came to talk about nuclear power and nuclear power engineering. I have two of my colleagues waiting for you with their presentation and also waiting for your questions. So if at any time during the webinar you have anything in mind, anything you want to ask, anything you want to add, any topic you would like us to concentrate on, you can open the Q&A section on the right side of your screen and type your questions in. I will collect them, and in the second part of the webinar there will be enough time to answer all of them. So don't hesitate, write your question as soon as they pop into your mind. But let's get to today's topic and to nuclear power. We were talking a lot about renewable resources and about the classical sources of energy, but we feel like nuclear power engineering is still a key part of our business. And as you can see in the chart, the volume of orders in this field has increased significantly in the last 2 years. To get to more specific points, we have two of my colleagues, as I already mentioned. First of them, Jan Homut, who will be telling you more about power engineering and why is nuclear power the key part of our business and the key part of European energy mix. And to concentrate more on the technical part of our products for nuclear power, to tell you more about the requirements of our customers and the state regulators, and also about cybersecurity and the safety and security of our products for nuclear power, is Martin Konop, speaker you might remember from last year and the previous Zoomat Technologies. So, as I was saying, we have a lot of news in nuclear power engineering and nuclear power industry in the Czech Republic in the current time. It is, we find it is a good news that only yesterday our state office for nuclear safety issued a permit to build new nuclear power source in a small town in our country, in the Czech Republic, called Dukovany. And it is one of the reasons, but not the only one, that we became a member of Czech Power Industry Alliance. You can see on the right side 10 Czech companies that are cooperating in the alliance together in the process of choosing the supplier for the new nuclear source in our country. We as an alliance declare that Czech industrial companies are more than capable to supply not only control system but also other technologies for the building of this new nuclear source, no matter who is the company to build it, we can cooperate with anyone who is currently in consideration. And to stay on top of our game, we also need to invest not only in our infrastructure, but also in our products. And we cannot invest only in the products for the bigger nuclear power plants, as I was mentioning before, for example, in Dukovany, but we also need to develop new products for the future development of nuclear power, and that might even be small and modular reactors. So that is what we are preparing for. That is why we are investing, because it is a very demanding field and we like to have all the cutting edge technology we can get to our customers. But it is time for me to let the experts speak, because I believe the topic was introduced enough. As we were talking about in the first workshops, renewable resources are playing bigger and bigger part, but we as a company believe that nuclear power still has a potential. It's still worthy of our attention. And let me give you Jan Homut, who will tell you why we as a company think that it is this fact.
Hello. Renewable energy sources such as solar system, wind farms have a future, but you still need a lot of stabilizing energy to maintain the stability of the grid. Our colleagues talked about renewable energy sources in previous session, and you can watch it online. The nuclear is a stable and reliable source and reduces the risk of instability of entire energy grid. In contrast with other non-renewable sources, the nuclear energy is almost carbon-free. Here is in this chart, you can see how much CO2 was emitted during the operation of the power plants, including construction. The whole chart is converted to 1 gigawatt-hour of energy supplied to the energy grid. When we compare the coal-fired power plant, nuclear power plant, but also the oil or water power plant, a huge difference can be seen. Another advantage of nuclear energy is the small dependence of the final price of electricity for customers compared to the price of the fuel. If the price of uranium increases by 50%, the price of electricity for customer will increase by only 2.7%. Unlike coal, where increasing the price by 15% will increase the price by about 8%. The cons of nuclear energy are high investment costs, the long-term investments, the need to store spent fuel, complex legislative process, geopolitical pressures, and social acceptability. And Martin will tell us how that contributes to the safety of nuclear power plants, to social acceptability.
Thank you, Honza, and hello everybody. So what we do to make nuclear energy safe and thus acceptable from society point of view, let's start with basic information about ZAP. ZAP is long-term supplier in the field of contracts with a high number of security requirements. We have 47 years of experiences in supplies to the area of nuclear energy. But it's no longer just the area of nuclear, but also the transport or healthcare. And what comes to your mind when I say safe? It's safety, nuclear culture, safety and security, safety and health, graded approach, FMA, FDA. So, as you can see, the term safe can be explained in various ways, or safe or safety, which is in standard common. However, what is important is to take it into account all these views and work with them parallelly, because each of them separately does not mean anything. Anyway, safety as a sum of various views is useful to turn into a sum of requirements, and it will help us to fulfill them and help us with the traceability. So we have requirements for legislative requirements, especially from countries where resources are operated, requirements of standards and recommendation, functional safety requirements, and last but not least, or we can't comment, the cybersecurity. Let's start with the legislative requirements and requirements for the standards. You must know yourself how many of them are necessary to be met today. Can you guess how many of them we have for one system in the field of safety? For example, let's say our product of RFCS for VVR 440. There are 10 of thousands of them. And to be able to meet all of these requirements of the mentioned various pieces of safety, it was necessary to match these requirements to the related activities, to introduce new processes to them or add the existing processes and interconnected these processes with each other. So, thus there has been established a map of process, as you can see. And as you can see, the map connects the processes start from daily operative activity through project and products up to individual strategies. By the way, can you guess where in this map the project for the field of safety and where the field of non-safety are hidden? Because we must forget that that applies not only to the field with high requirements of safety. Yeah. What if I say that nowhere? Of course, they are practically there, but they are in the form of graded approach, which is besides that based on our own levels of safety. And these levels of safety combined with graded approach will enable us to meet even the most demanding safety standards without burdening the creation of products less demanding from safety point of view. The graded approach gives us in the fact the scope of documentation and activities required for a given level and is in such a way that we support as much as possible licensing process, user-friendly, supporting of long life cycle, or verify through testing and simulation the faultless character even at the phase of product design. So in other words, that our product is safe. And how successful we are at going through the qualification in various countries is illustrated based on the map of our references, as you can see, from nuclear power engineering. As you can see, we have successfully passed and deal with the legislative requirements for the nuclear safety of 7 countries, which is a great experience for that. When we speak about the functional safety or cybersecurity, then it's necessary to mention our own technical means. These technical means, among which there belong both our own control system and the design means, are developed based on the long-term experiences from projects with high requirements for safety. Most of these means, let's say tools, belong to the platform Sandra, which contains 2 main lines, namely the yellow line Z100, which we use for safety area, and green line Z200 for safety-related systems and for non-safety. Product Sandra Synergy, which is control of class DCS, is also based on these means. But the platform Sandra is not only one platform that we have. All that also has a platforms of technical means, for example, for the field of IoT, or let's say industry IoT in our case, or the field of processing and analysis of big data. In case that you are interested in some of these platforms, I would like to recommend you seminars that focus on this platform, e.g. from technician to manager or 21st century healthcare. To make a conclusion, I would like to add that our tools are not only safe, but also on a very high technical level, thanks to cooperation with universities and research organizations. Let's give some example. We were member of Project Canut. It was focused on advanced nuclear technologies, and in this 8-year project, in which cooperate universities, research centers, and companies, our task was to implement innovations in practice. Some examples of projects that we put in practice are power controller of nuclear reactor, reactor simulator, or the system of category A according standard 61226. This big project has started closer cooperation with these institutions and help us to keep our technical means at a modern level. And now back to Honza, who will tell us which trends we can expect in nuclear power engineering in the future.
Thank you. As you know, the nuclear energy has many undeniable advantages. Unfortunately, it also has several negatives, such as high investment cost in this construction. But small modular reactors seem to be a solution for this problem due to scalability and mass production, which is significantly cheaper. Other expected benefits include simplified decommissioning, a small emergency planning zone, and above all, a high level of passive safety. As ZAT has experience in the control of large PVR reactors types, it is competent to supply the systems even for small light water reactors. References from Brazil or wherever provide that is in that we are also able to participate in research and development of innovative type of reactors, such as high temperature fast reactors cooled by liquid metal. There are 70 types of SMRs in development around the world these days. It is a question of which of these projects are eventually implemented and when it will be possible to use them in Europe or in Czech Republic. On the other hand, what we know for sure is that there are approximately 440 nuclear reactors in operation around the world. Therefore, extending the lifetime and modernization of such reactors is a hot topic. And Martin will tell us about the innovative technology that we developed at ZAT regarding the modernization of existing reactors.
Thank you, Honza, for this nice question, because I have one example. Using our professional competencies, mathematical models, and known algorithms from IT, we have developed a more precise evaluation of position capable of work even in case of simple failure of sensor or cable rope for the system of reactor load control VVR 1000 and VVR 1200 or RRCS system. It means that advantages are represented by shortening of the maintenance period of the system during planned shutdown, the lifetime of 30 years, and improvement of the core zone quality when there is available large diagnostic of the mechanical state of drive, cluster, and fuel assembly, while keeping identical cabling. This solution has been incorporated in platform Sandra, and the research has resulted in joint patent with JS. With that, we cooperate in this research. And now back to Honza, who will tell us about the topic of extending the service life and modernizing power plants.
Okay, the service life of a nuclear power plant today is projected at 60 years. Reconstruction or replacement of the control system is considered every 20 to 25 years when the switchboards of the control system cabling and possibly the part of the technology are replaced. For comparison with coal-fired power plant, the reconstruction is usually carried out every 10 to 15 years. At that, we are able to ensure the gradual migration of the control systems too. For example, every 15 years, when only some parts of control system are modernized. For example, at the Dukovany power plant, racks of older generation ZAT premise system are gradually being replaced by up-to-date ZAT Sandra system without replacing of switchboards or cabling. The benefits, it's a short outage, the distribution of investment over several years, the possibility of increasing of comfort of operation and maintenance, or increase of safety. Of course, because we monitor the availability of the components for our system, we are able to update the component base of the board level, which occurs approximately every 10 years. And I would like to ask Martin for a brief overview of what we are working on.
Okay, and what we are working on briefly. Besides the permanent modernization of our platforms, we are currently working on support the control and evaluation of position of control rods of different manufacturers. We are also working on more effective architecture of RRCS product concerning a big amount of drives for VVR to 1200, where we use the experiences from the project for VVR 440 and VVR 1000. However, thanks to its modular concept, this product can be simply modified for other types of reactor, for example, generation 3 plus at VVR 1200. So currently there is now being elaborated a new product for control of VVR 1200 reactors at the Sandra Z100 platform. And here I could show you how this evaluation of position of reactor controls for other manufacturing looks like. So you see it's only part of our platform that I said that it's based on modular concept. And before we start replying to your question, I would like to get back to Mara for a short summary.
Thank you, Martin. Thank you, Jan, for your introduction and for your insights of today's topic. And as Martin mentioned, now comes the time for your questions. Now is the correct time to go to the right side of your screen and ask anything you would be interested in, you would want to hear in the second part of today's webinar. And as I can see some questions already piling up, I can also see some of you find the option to like the question. This is another type of communication with us, another way to let us know what you are interested in, what you want to hear. So if you like any question already published, don't hesitate, give it a thumbs up and I will know to answer it at the beginning of the next part. And while you are submitting your question, let me summarize really briefly what we heard today. My colleagues were talking about why ZAT is a strong player on the market of nuclear power and nuclear power engineering. Our company is built on more than 60 years of experience, and 47 of these years were dedicated to supplying for nuclear power plants in 7 different states, as you can see on the flags on the bottom right side of the window. We are in compliance with the requirements of 7 different state nuclear safety authorities, and that is why we have enough experience to supply to different states over Europe, and why we are successful in audits from our customers with high ranking. And another key part of the success is our own control system, our platform Sandra, that has long life cycle, and that thanks to our own development and our own manufacturing can meet any requirements our customers might have, and can be modified to work with different types of technologies and different types of reactors. And we are still developing it. We are following the trends both in bigger nuclear reactors and in the small modular ones. So these were the key points why we think nuclear power engineering is the right way to follow, and why we think we are ready to anything that the future in nuclear power might bring us. And now let's get to your questions. Let's hear what you want to know. And the first question here is about the small reactors. Jan, can you tell our viewers what can we supply for small reactors?
Okay, thank you for your question. Our systems are ready to control the primary and secondary part of nuclear power plants composed of the smaller modular reactors too. For example, we have experience with regulation of the heat exchangers based on molten salts from solar concentration power plant, and it's possible to use this technology in some types of SMRs. I must also mention our supplies for low power research reactors, for example, in Brazil or in Czech Republic in Ujeveř.
Thank you for your answer. If any one of you is interested in something more, if something Jan was saying was unclear, you can ask a follow-up question. You can also just mention any topic you would like to know more about, and we will address it. And now to get to the next part, I have a question here that I think is the best person to answer is Martin. Martin, how do we ensure cybersecurity in our projects? One of our viewers would like to know, other ones are giving it a thumbs up, so can you give them the answer?
Thank you, Bara. I understand it's a very common topic in these days. Let's say we were interested in it, and we consider security as an automatic part of all our projects. So it must be incorporated from the very beginning. It means in our tools. And it's then is it the security included in the project and in the company itself? Anyway, like with the safety, the security is also about an intensive cooperation with our customer, and we must consider security together with this customer, because he only knows the aspect or which aspects are crucial in his project. Security as well as the safety is a process realized through the tools that we control. As I said, we developed almost all our tools for developing this project and products. So we separate or dividing the cybersecurity to three main areas. So to company, it's one, to project, and to the products. In company, it's traditional about cybersecurity policies, and let's say about training of our employees. In project, it's about assessing the project from the point of view of security, and again training the designers in this area. And last but not least, in product, we use our own operation system, our own communication proprietary software. We use hardware barring, which is common even in the safety again, and we adding the security aspect in all levels of this product. I hope it's enough details. If you would like to ask more, don't hesitate to ask.
Thank you, Martin. And as you said, don't hesitate to ask questions. I can see some more coming up. And let's get to the next one again for Jan. Jan, our viewers would like to know, how can control system further increase the efficiency of nuclear power plants? Can you answer this to our viewers?
Yes, there are several possibilities how to increase efficiency of nuclear power plants. For example, development of more precise regulation of primary or secondary circuit, or the regulation of reactor power. Of course, thanks to our experience from conventional power plants, we are able to modify system for greater utilization of heat supply from nuclear power plants. This will increase the ability to control nuclear reactors, as well as it brings efficiency gains.
Thank you. If it was all, I hope it was. I hope I wasn't interrupting you, but it looks like it's the case. So we can move to the next questions. I can see some more coming up, and if we still have enough time. So if you have anything in mind, don't hesitate. Go to the right side to the question and answers, the Q&A, and ask anything you would want to hear, because that's the only way you can leave this webinar with all the information you wanted to hear, if you let us know what you want to hear. And now let's get back to Martin. Martin, our viewers are interested in the fact, how do we meet the requirements resulting from legislation, standards, customers binding regulations, and local authorities in a particular country? Can you get back to that?
Yes, of course. Let's start that we have prepared complex metrics for, say, every standard which we have to pass. Initially, it is complex matrix for the standard only, but when this standard is, let's say, for generic application, we build it into our processes. As next, we have standard documentation prepared for most of licensing procedures and audits. As it's known that we are part of licensing process and we have activities according to safety processes. So we respect not only standards developed for nuclear safety, but to, let's say, we respect the industry standards. As I said, in those webinars, it's useful to see on this as a, let's say, from point of view of requirements. And we have great system for requirements management, and even the configuration management help us to this. So we are able to trace, we are good in traceability, and we could trace, let's say, from requirements of customer to final projects and even back. So even in HMI, I could see few of us, let's say, in configuration management from the requirements. So I hope it answered for me. If you would like to more, do not hesitate to ask.
Thank you, Martin. Thank you for your answer. And let's move to a quite a little bit different topic, a little bit similar, because it also connects to the countries where you can find our control system. Jan, one of our viewers is curious, in how many NPPs can we find our control system? Can we even count it?
Yes, we have references from 4 units in Magyar, in Hungary, 1 unit from Armenia, 4 units from Slovakia, 6 units from Czech Republic, of course, 9 units from Ukraine, and 1 unit in Finland. And of course we have 20 units in France, but not with own control system. This is only with that cabinets. We are active on 33% of European Union nuclear power plants. It's a huge amount, and it's 10% from nuclear power plants around the world.
Thank you, Jan, for your answers. So you can see that it is really hard to count, because we have different different numbers of units in 7 different countries all over Europe. If you are interested in our references in nuclear power a little bit more, I would like to direct you to our YouTube channel, where you can find a video talking about different NPPs in different countries. So you might find that interesting. On the YouTube channel, you can also watch the recordings of the previous webinar, and also today's webinar will be available after it's finished. So if you joined us later on, no need to worry, you can watch the beginning from recording. So we are almost done with all the questions here. I can see some last ones. So if you are interested in something, if you want to know something, if you want to focus on a specific topic, please do not hesitate. This is the right time to stop being shy and write us, because otherwise this webinar will end without your question answered. And to move to the next question, again connected to nuclear power plants, what products are we able to supply for the nuclear power plants? Jan, can you get to that question, and maybe Martin will like to add a little bit more to that later on?
Sorry, Barbara, please repeat me a question.
Oh, I'm sorry. Okay, one of our viewers would like to know what products are we able to supply for nuclear power plants?
Thank you. We supply the safety system and safety-related system for the control of primary circuit technologies such as reactor power regulator, safety shutdown systems, reactor rod control systems, control of general technology of the primary circuit too. Furthermore, for control of secondary circuit, for example, the control of protection system of the steam turbine, the excitation system of the generator, the control system of course, we are able to deliver the general technology, the control system for general technology of the secondary part. For common block parts, we are delivering information and control system for mine control room, emergency control room, and complex solution for control of balance of plants and balance and controlling of every technology in nuclear power plant.
Thank you, Jan. So this was the last question we had here. So unless any one of you sends me something in the last few minutes, I will be ending this webinar. I would like to thank you for your attention. I would like to thank you for your question. And if you were watching more than just this one webinar, I would like to thank you for being us for the whole time. As you could see in this year's ZooMed technology, the range of fields where we are active is quite wide. We start from power engineering and our platform Sandra, and we move to smaller industrial companies. And with our platform Simonet, we can bring you new possibilities to monitor, collect data, and visualize them, and then make qualified decision. So if you are our customer, for example, from the power engineering sector, do not hesitate to watch the webinars concentrating on the Simonet platforms, because you could use the products based on this platform in any type of facility, any type of company, any type of industrial area. And if you want to stay connected with us, even after this year's ZooMed technology ends, you can follow our website, you can follow our LinkedIn profile, or you can connect with me or my colleagues directly via LinkedIn. And we are happy to discuss anything you weren't able to ask here on this more personal base. We are also already preparing for ZooMed Technology 2022, so don't be afraid, because next year at winter or at the beginning of spring, We will be here on this virtual platform again, ready for your answers, ready for your questions. Cannot wait to give you answers and to tell you more about the changes and the innovation that our company is bringing and how the fields we are active in are developing. So that was all from today. That was all from this year's Zoom Technology. Thank you again, and I hope we can see you again soon with through our social networks or with next webinars. Thank you for your attention. Have a nice afternoon and bye.